we know the basic difference between the open loop system and closed loop system. If you look at the block diagrams of open loop and closed loop, from the first instant itself, we can say that the difference is the feedback. In open loop system, the feedback is missing. In closed loop system, there exists feedback. Now, we will see what are the effects of feedback in control systems. Now, so this open loop system is also called non-feedback system, and this closed loop system is now it is a feedback system. So let us look at what are the effects. Now I just want to concentrate the effect of feedback on these parameters. The first one is the gain, and second is a pole location and time constant, and third is impulse response of the system, and then on bandwidth, and then on the sensitivity of the system, which is very important in the control system. And also we will see what is the effect of feedback on noise or disturbance on the system. So not only this, what will be the effect of positive feedback, which is also called regenerative feedback on the system. Now let us start with the effect of gain on control system. So we will try to look at what is the open loop transfer function and open loop block diagram. The open loop block diagram is going like this. So I have a block inside the gain G, and there is input connected, and we have the output. So this is usually called the open loop system. But what is open loop control system? When I say open loop control system, the controller is also part of my system. Then look at here. So this is a controller, and after that we have system, and input is given to this controller, and output we are taking for the plant as a system. So for analysis purpose, what we can do is we can see we can combine these two blocks and make it a single block G, which is my open loop block. Now what is the transfer function of open loop system? Now it is only simply G. What will be the gain of it? The gain is nothing but G. Now what is a closed loop, or what is a feedback system? So for the feedback system, you can see here this is G and this is H, and we have a negative feedback. All the effects are a negative feedback effects which we are going to see. So input is R of S and output is C of S. What I need to do is I need to find what will be the closed loop transfer function of the system. What will be the net gain of the system, which we want to know. So which we know that, then I can compare with the non-feedback system, and I can make one statement. Right. So how to do that? Let us take intermediate signals in this block diagram. The first signal which I am taking after summing point, which is E, and after this feedback H, I am taking it as a B. Then we can write very easily what is the output C. C is nothing but E into G. Then what will be the C again? What is E? E is nothing but your R minus B or R minus H into C. Then we can substitute here. Then we can find out the relation. C into, so 1 plus GH is equal to RG. I can find out the transfer function C of S by R of S, or simply C by R as G by 1 plus GH. So G by 1 plus GH is the transfer function of closed loop system, or the gain of the closed loop system. Now what will be the open loop? So open loop is non-feedback. For non-feedback, the gain is G. For feedback system, the gain is G by 1 plus GH, which means for feedback system, the gain is reduced by the factor 1 plus GH. So whenever you close the loop, the gain reduces. So which is the result of the feedback and non-feedback system. Then we take the second, the effect of feedback on location of pole or time constant of the system. Now let us take again non-feedback system, which is open loop. I am taking this is G, and input and output which are there. I am just going to look at the dynamics of it. For example, if I take the G of S as, for example, K divided by 1 plus S T naught. So T naught is the time constant of my open loop system, and K is the gain of the open loop system. Now what is the time constant of this? Simply T naught, right? So when you look at the closed loop and assume my feedback is unity, H is unity, then you know what will be the closed loop transfer function C of S by R of S, which is G by 1 plus GH. Then take G as it is, K by 1 plus ST naught all divided by 1 plus again G is K by 1 plus ST naught, H is 1. So the result is going to be your C of S by R of S gives us, we have K by 1 plus K, and the denominator we can write it as 1 plus s into t naught by 1 plus k. So what is the time constant? The coefficient of the term s is a time constant. Then what is the quotient of s here, which is t naught by 1 plus k. So t naught by 1 plus k is a time constant. For non-feedback system it is only t naught. Then what will be the result? Then I can say that the time constant of closed loop system is reduced by the factor 1 plus k. So again we will see, that means for non-feedback to feedback we have a decrease in the time constant of the system. We know time constant is very important parameter in any system, which will give us how fast your system is reaching to the steady state value. Now we can look at what is the pole locations. The pole location of open loop is very clear because t naught is my time constant, my open loop pole is minus 1 by t naught. Then what will be the closed loop pole time pole from the time constant of the closed loop system? We can write it as, let us say, Tc is my pole, then that is S is equal to, we have the location at minus 1 plus k by t naught. Now let us see an S plane. Let us say this is my S plane. We know S plane is a complex plane where we can locate poles and zeros of the system. Now I have open loop pole and closed loop pole. Let us locate them. So first look at what is the open loop pole. Open loop pole is minus 1 by t naught. So I am just locating here, it is minus 1 by t naught. Then I want to locate the another pole, closed loop pole, which is minus 1 plus k by t naught. So that will be here. So what does that mean? So my open loop pole is nearer to the imaginary, my closed loop pole is going away from the imaginary. So whenever you have a feedback system, whether it is a unity feedback or if you have any other feedback, then you will have always a closed loop pole which is away from the imaginary, which is again away from the open loop pole. So this way I can say the time constant as well as the pole locations of my feedback system when compared to non-feedback system. Then we will see what is the effect of impulse response of the system. So what is impulse response? So impulse, we know it is like infinite pulse. So the impulse is like a spike which we have like this. Now, so what is the Laplace equivalent of impulse? Laplace equivalent of impulse is 1, which means the input which we are giving is 1 and we need to look at what is the output of the system. We can directly say output is C of S. When you apply the inverse Laplace transform to that, you will be getting the impulse response of the system. Let us take the non-feedback system, which is the open loop system. So in the open loop system, what is the transfer function? Your transfer function G of S is, we already seen it is k by 1 plus s t naught. Then if you rearrange in the form numerator, I can write it as k by t naught divided by, you can write it s plus we have k by t naught. So whenever you have k by s plus a, the inverse Laplace is going to be k in t power minus at. Then when you apply inverse Laplace here directly, we are directly applying inverse Laplace because the impulse input is equal to 1 in Laplace domain. So what will be the C of t? The C of t is going to be k by t naught is the constant you are getting. Then e power minus t, small t is a time parameter, and you have a. So a is nothing but your k by t naught. So k by t naught into e power minus k by t naught into 2, which is the response of the system, and it is very clear the starting point is k by t naught and it is exponentially decreasing as the time is increasing. Similarly for a closed loop system, we know for closed loop system C of S by R of S, we can find the transfer function where G is my k by 1 plus S tau. Then if you do this, and you will be getting it as, anyway R of S is equal to 1 for impulse. Then your C of S, first of all we write the C of S as, we have k by t naught over, we have S plus 1 plus k by t naught. So 1 plus k by t naught is A and k by t naught is k. Again whenever you have k by S plus, the inverse Laplace transform is k into e power minus at. Then what will be the impulse response? For closed loop system or feedback system, the impulse response is going to be your C of S is k by t naught and e power minus t, small t, into 1 plus k by t naught. Then if you look at the impulse responses of these two, I am just taking the plot here. This is x-axis. As the t is increasing from 0 to infinity, what will be my c of t, the response of the system? In this case, impulse response. Now, so in both cases, the starting point is same, means my open loop response is also starting here and closed loop response is also starting here, which is k by t naught. But they are reaching to 0 as the t tends to infinity, e power term going to 0, so both are going to 0, but in between how they behave is the most important thing. Now, open loop we have like this and closed loop we have like this, which means my open loop system is slowly going to 0, and whereas my closed loop system is taking very less time to reach the steady state value. What I can say here is from these two graphs, the closed loop system, which is a feedback system, always faster than the non-feedback system, that is your open loop system.